Hello, welcome to Target IAS. I am Om Prakash Rajput, and today we will see some questions on electrostatics. So here is our first question on electrostats. A perfectly conducting metal plate is placed in xy plane in a right-handed coordinate system. A charge of plus 32 pi epsilon naught root 2 coulomb is placed at this coordinate 002 as shown in this figure. Epsilon naught is permittivity of free space. I, j, k are unit vectors along x, y, and z axis respectively. So at the coordinate root 2, 0, here we have to find electric field in Newton per coulomb. So we have to find at this point electric field due to this point charge. But here this is a metal, this is a perfect conducting metal plate, and when a charge is placed on a like this with having a metal perfect conductor metal plate, we have to apply image theory. So using image theory, what happen is here the charge is plus 32 pi per pi epsilon naught root 2, and at the same distance that will be 0 comma 0 comma minus 2. This is at 002. So the other charge will be at 00 minus 2, having minus charge 32 pi minus 32 pi epsilon naught root 2 coulomb will be the negative charge which is placed at the 00 minus 2 using image theory. So due to these charges we have to find this electric field, and we have to choose which option is correct. So let us see. Now these are basically what point charges. So electric field will be sum of the electric field due to individual charge. So let us take E is the electric field, net electric field, that will be sum of 2 point charge electric fields, that is E1 E2. So due to a point charge, if you remember what is the electric field, it is 1 by 4 pi epsilon naught q by r12 magnitude cube, and in the direction r12. Like similarly for the other charge also it will be the same formula. So we have to find this r12 first. Okay, for both of them we have to find this r12 here to here and here to here. So what I have told is how this can be find out. So r12 for, suppose this is r1 and this is r2. So r1, if I just rub this directly, I will put the values. So r1, what it will be, r1 will be equals to field location minus source location. So it will be root 2 I cap plus root 2 j cap. 0 minus 2 will be minus 2 k cap. And similarly r2 vector will be here root 2 I cap plus root 2 j cap, and 0 minus of minus 2 will become plus 2 k cap. Understood? So we can now simplify this. Here if I use the formula for E1, it will be 1 by 4 pi epsilon naught into q. Q is 32 pi epsilon naught root 2, right? uh, and what will be here r1 magnitude, it will be, I will first write the vector root 2 I cap plus root 2 j cap minus 2 k cap, and then magnitude to the power 3. So it will be root 2 square, that will be 2, plus root 2 square again, that will be 2 again, and minus 2, that will be 2 square actually. Here it will be 2 only because root 2 square is 2, and here it will be 2 square to the power 3 by 2, right? So let's cancel what are the terms which are getting cancelled here. So you can see that this 4 pi cancel this as 8, epsilon naught gets cancelled, so only thing remaining is 8 root 2 into what is here root 2 I cap plus root 2 j cap minus 2 k cap. And if you solve this part, it will come as 2 plus 2 4, 4 plus 4 is 8, 8 is 2 root 2, and it will be 16 root 2. Okay, it will be 16 root 2. So you can simplify this as just 1 by 2, and here this will be root 2 I cap plus root 2 j cap minus 2k cap. Right, we can find E2 due to this negative image charge. It will be similar to that, just a negative sign, and position vector is changed. Minus 32 pi epsilon naught root 2 into, what is the position vector for this? It is root 2 I cap plus root 2 j cap, minus, instead of minus it will be plus 2k cap, and for this magnitude it will be again what, same 16 root 2. So we can directly simplify this as few things getting cancelled, like here this epsilon naught and 4 pi makes this minus 8 root 2, right, and this root 2 will get cancelled. Here this will be remaining minus 1 by 2 root 2 I cap plus root 2 j cap plus 2k cap, and if you add both of them, total electric field, that will be 1 by 2 can be taken out common, root 2 I cap plus root 2 j cap minus 2k cap plus root 2, here it will be, because of this minus, becomes minus root 2 I cap minus root 2 j cap and minus 2 k cap. So you can see many things are getting cancelled here, this root 2 I, root 2 j. What is remaining? Just the remaining things is this minus 2k becomes minus 4k, and outside there is a 2, so it becomes minus 2k Newton per coulomb. This will be the final electric field due to this arrangement of charges. So from the given option, option B is the correct option. Okay, so this was a very simple question based on image theory. Hope you understood it. Now let us see one more question. The figure shows a diagrammatic representation of vector fields x, y, and z. These are here shown as vector fields. So you have to, which one of the following is true? Here there are options like this. So you have to check either they have divergence or curl. So if you remember, for a field to be divergent, I have said that if the field is like this around a point, then its divergence is positive, and if it is incoming, its divergence is negative, and if it is like this, so it will have zero divergence. And for curl, if you see, what is that? Measure of how much a field rotate about any point. So if the field is rotating about any point, then the curl of the field will be non-zero. And if it is like this, it is not rotating, it will be irrotational or conservative field, and its curl will be zero. So here also you have to just check that whether the divergence or the curl for the given fields are zero. So if you see, for this field there is no curl. For this field, if you see that del cross x is 0, but the divergence of this field is non-zero because it is diverging from this point. Okay, now here if you see, the field is not diverging, it is basically just curling, right? So for this, if I have to write, I will write del dot y equals to 0, but del cross y is non-zero, right? And for z, if you see that this field is diverging and also rotating about a point, so here the curl, or I have written divergence, is non-zero, and curl is also non-zero. So from the given option, if you see, like A option given that del dot x is 0, so this can't be correct. Del dot x is not equals to 0, this can be. Here del cross y is non-zero, this can't be correct. Here del cross x is non-zero. Del cross x, not del cross x, it is del dot x. Del dot x, that is divergence, is non-zero, right? This is true. Del cross y is non-zero, yes, and del cross z is non-zero. So this option, C option, is the correct option. Okay, if you see the D option, that is del dot x is 0, so obviously it's not correct. So C option is correct. So you can easily find that which field is having curl and which field is having divergence. Okay, now let us see another question. A parallel plate capacitor consisting of two dielectric material as shown in the figure. The middle dielectric slab is placed symmetrically with respect to plates. If potential difference between one of the plates and nearest surface to the dielectric interface is 2 volts, then ratio of epsilon naught 1 to epsilon naught 2. So here you can see that this plate having 10-volt potential and this plate is grounded, and this dielectric epsilon naught 2 is symmetrically placed between these plates of the material epsilon 1 and epsilon 3. It is actually epsilon 1 only, because similar dielectric इनके बीच में placed है. Okay, so you have to find ratio of epsilon naught 1 to epsilon naught 2, epsilon 1 and epsilon 2. It is also said that the potential difference between one of the plates and nearest surface to the dielectric is 2 volt. So the potential difference here is 10. So if we see that potential difference between these plates will be 2 volt, and as these are basically what combination do you feel that this is having? This is like a capacitors connected in series. Suppose this is C1, this is C2, this is C3. Here C1 and C3 will be having same distance only, will be having same capacitance only, because here epsilon 1, here epsilon 1, and the distance also, if we see here d by 4 and here also d by 4, so that it will make d by 2 and d by 2 and complete d. So you can see that C1 and C3 are in series. I mean same, all are in series. C1 and C3 are same. So as this potential is 2, so this potential will also be what? 2. So total potential between these plates is 10 volts. So what it will be? Here if I write, it is V3, because I have taken for it for C3. So what the V2 will be? It will be the remaining thing. So total it is 10. So 2 plus 2 4. Here it will be 6 volts. Okay. Now if you see, these are connected in what? Series. So we can combine these two capacitance C1 and C3 and find uh, one equivalent capacitance, and then C2, just to make it simple. So if we find C dash, what is the formula for combination of series? It is 1 by C1 1 by C3 inverse. So it will be what? C1 C3 by C1 plus C3, right? C1 C3 by C1 plus C3. It will be the value of capacitance. So if I write the value in terms of permittivity, it will be, you can see here, the area of plates is same for all, right? So let us take, it is A. The distance for C1 is d by 4, so it is 4 epsilon 1 A by d. Similarly C3 will also be same, 4 epsilon 1 A by d, right? So if I find C dash, so it will become 16 epsilon 1 A square by d square, and if I add these two, so it will be 8 epsilon 1 A by d. So you can simplify this as 2 epsilon 1 A by d. 2 epsilon 1 A by d, right? And for if I write for C2, it will be epsilon 2. Area is same, the distance is d by 2, so it will be 2 epsilon 2 a by d, right? Now, as you know that what is capacitance? Capacitance is charge divided by potential between these plates. So as they are connected in series, the charge is going to be same for all. So you can say that capacitance is inversely proportional to what? Potential. So you can find using that C dash by C2 will be equal to what? C dash by C2 will be equals to what? V dash by inversely proportional, so it will be V2 by V dash. And what will be V dash? V dash is the effective potential on both of them, C1 and C3. So V dash will be V1 plus V3. Okay, V dash will be V1 plus V3. So it will be 2 plus 2, 4 volts. Right. If I put the value of capacitance, it was here C2 C dash value is 2 epsilon 1 A by D, 2 epsilon 1 A by D, and the value for C2 was 2 epsilon 2 A by D. This will come as V2 was 6 volts and this was 4 volt, right? If I cancel these things, so I will get the ratio of epsilon 1 and epsilon 2 as 3 by 2. Okay, so this will be the ratio of epsilon 1 to epsilon 2. So hope you understood this simple question based on the capacitors and dielectrics. Okay, so ratio of epsilon 1 is to epsilon 2 is 3 by 2 or 1.5 you can say. Now let us see next question. Two semi-infinite sheets are placed at right angles to each other as shown. A point charge Q is placed at a distance d from both the sheets as shown. So these are two semi-infinite sheets, and this charge Q is placed d distance from this y plate and x distance d distance from this x plate. So the force on the charge is this much, q square k by 4 pi epsilon naught d square, where k is given by which of the following option is correct, we have to find out. So this is again another problem on what? Image theory, because these are two semi infinite sheets. ठीक है, तो ये भी क्या है? कंडक्टिंग परफेक्ट कंडक्टिंग प्लेट्स ही हैं. ठीक है, यहाँ पर टू सेमी इन्फिनाइट, these are conducting sheets, these are conducting sheets. ठीक है, गेट का ही क्वेश्चन है ये. तो ये भी इमेज थ्योरी पर बेस्ड है. तो हमको पहले तो क्या कहते हैं, इन सेमी इन्फिनाइट शीट्स को रिप्लेस करना होगा बाय इक्विपोटेंशियल सरफेसेस. इट विल बी लाइक दिस. ठीक है, यहाँ पर ये इक्विपोटेंशियल सरफेस मतलब कि कुछ इस तरीके से होंगे एट राइट एंगल्स. दिस चार्ज इज विल बी प्लेस्ड हेयर, and due to this plus q charge and the distance here is d, what it will be? There will be an image charge here of minus q, and the distance from here to here will be d, and due to this plus q charge here also at the same distance d, from here a minus q charge again will be there as image. Now due to these minus q charges there will be again an image charge here, which is, if I make this as line here and here, so this distance will be again what? D, and this distance will be again what? D, and here due to this minus q and this minus q the charge will be plus q. So it is like a it is like that the charges, if I consider this as my origin, so charges are placed on a square, basically corners of square, vertices of square, and the distance or if I say the side of the square is 2d, the side of the square is 2d. If I consider this to be my origin, so what will be the coordinates of this plus q charge? They will be what? D comma d. As there is no requirement of z, so I can take only x and y. So d comma d will be the coordinates of this, and here the coordinates will be what? For y it will be minus d, so it will be d minus d, and for this it will be minus d, and for this it will be uh, minus d, right? So now I have to what? Find out the force on this plus q charge due to this arrangement. So what is the force given by? So I can find individual force and add all of them. So you can see what is the force formula: kq1 q2 by 4 pi epsilon naught, the distance between them, and some r vector. If I write in the form of vector, so it will be r vector magnitude and r vector, right? Here cube is there, so I have to apply this formula and find the total force. So I can find the force. First, finding the force due to this charge, it will be what? As this charge is negative, so I can take few things common. Here I have written q 4 by epsilon naught only, so I have to write this k. So the force will be what? Q into minus q, so I will write here, and 4 pi epsilon naught, the distance between them is, you can see, what is the distance between them? It is 2d square, 2d square, or if I write in the vector form, so it will be 2d cube. Okay, and the r vector will be force location minus source location, force location minus source location. So I'm finding at this point, suppose this point is a, so it will be, so force location minus source location, d minus of minus d, it will be what? 2d ax cap, 2d ax cap, and the y component will get cancelled. Here the answer is given in format of ijk, so I can write 2d I cap in fact. Okay, now force due to this charge, it will be again minus q divided by 4 pi epsilon naught, the distance between them is also 2d, so I can write 2d cube, and the r vector will be given by force location minus source location. So d minus d will be 0, and d minus of minus d will become 2d. Here it will be j cap. Okay, here it will be j cap. Now force due to this one, so it will be, as these charges are positive, so it will be q into q by 4 pi epsilon naught. The distance between them is, basically these are square, so it is diagonally placed, so it will be root 2, and the side is 2d, so I can write in fact 2 root 2, 2 root 2 d cube, and the r vector, force location minus source location, so d minus of minus d, it will be 2d I cap plus 2d j cap, right? 2d I cap plus 2d j cap. Now I have to just take few things common. So here you can take q square by 4 pi epsilon naught common, and 2d in some places gets cancelled if I make this uh, cancel. So here this 2d will make this power square, here this 2d will make this power square, and here also 2d I can take common, and I can take 2d out. So it will be here, if I tell what will be remaining, if I take root 2 cube, and if it will be little here tricky, I mean not tricky, I'm just taking d square common. Okay, and I'm taking the numbers as it is, so it will be minus I cap, 2 and 2 will get cancelled, here it will be like 4. So same will be here, but of minus j cap by 4, right? And I have taken q square by 4 pi epsilon naught common, and d square is also common, तो ऊपर में क्या रह गया अभी 2 I can take common, so here 2 I cap plus j cap, and divided by this 2 root 2 square, basically 2 root 2 cube I have to solve. So it will be solved as 16 root 2, 16 root 2. So I have to just solve this, and when I solve this, it will be here, it will be 8. Okay, so here it will be 8, and you can see that the if I take for the I component here plus, and here the I component is 8 root 2, and here minus j cap by 4 plus, and here j cap by 8 root 2, and if you solve this, here the terms were q square by 4 pi epsilon naught d square. So it will be q square by 4 pi epsilon naught d square. Here the things which will be coming will be like 1 minus 2 root 2 by 8 root 2 I cap plus 1 minus 2 root 2 8 root 2 j cap. So if you see, they are in the form of which were given in the question, q square k by 4 pi epsilon naught d square, where k value is this one, where k value is this one, 1 minus 2 root 2 I cap by 8 root 2, and 1 minus 2 root 2 j cap by 8 root 2. So the from the given option, the D option is the correct choice. Hope you understood it. Now let us see one more question. Here a thin soap bubble of radius r equals to 1 centimeter is given. R equals to 1 centimeter is given, and thickness is 3.3 micrometer, and you can assume that this thickness is very much smaller than the radius of the bubble, and it is at 1 volt with respect to reference point at infinity. The bubble bursts and becomes a single spherical drop of soap, assuming all soap all the soap is contained in the drop of radius r. यानी कि कोई भी जो soap का content है वो lost नहीं हुआ, it's just transformed into this small drop. The volume of the soap in the thin bubble, you can take it as 4 pi r square, and this a is multiplied with this 4 pi r square. Okay, so this is 4 pi r square into a, where a is the thickness, and that of the drop is 4 by 3 pi r cube. The potential in volts of the resulting spherical drop with respect to the same reference point at infinity. So we have to calculate potential due to this drop with the same reference point which is at infinity. So what you have to think of, that it is like a spherical capacitor. It is like a spherical capacitor here, whose capacitance, suppose C1, is given by 4 pi epsilon naught and radius of this sphere. Right, you can think of this also as a spherical capacitor of radius of 4 value 4 pi epsilon naught into small r, because its radius is small r. So you have to think like that. Now if you see that here the potential is given, and you know that C1 is equals to q by v, and here potential for this drop, suppose V1, is given as 1 volt. Okay, it is given in the question that the potential is 1 volt for the this soap bubble. So you can write here in the place of C1, 4 pi epsilon naught capital R is equals to q by 1. So it will be this will be the value of the charge on this bubble. Now if you think of the soap of radius small r, that will be C2 is equals to q by v. Now this can be taken as V2. This charge q will remain same because all the soap is just transformed into this small bubble as said in the question, assuming that all the soap is contained in the drop. So all the charge will also be same. So you can write in place of q this value, and C2 is 4 pi epsilon naught small r is equals to 4 pi epsilon naught capital R divided by V2, and you can write V2 as the radius of small r, or the capital R in fact, uh, V2 as capital R divided by R, right, capital R divided by R. And if I take small r in centimeters and putting the value of R, capital R, as 1, so V2 can be found out by this. So just we have to find out small r value. So as said in the question, that volume of this big bubble is 4 pi r square into A, and volume of this small bubble is 4 by 3 pi r cube. So we have to just equate this because all the soap is transformed into small bubble, so volumes will not be changing. So 4 pi capital R square multiplied with A equals to 4 by 3 pi r cube, small r cube. Here this 4 pi and this 4 pi gets cancelled. R value in square, if I write in centimeters, so it is 1. A value in centimeter, it is given 3.3 micrometer. So if I write in meters, it will be 3.2 into 10 ki power minus 6. If I write in centimeters, it will be 3.3 into 10 ki power minus 4. Right, this will be 1 square, there is no denominator, is equals to r cube divided by 3. So if you solve this, we get the value in centimeters as, if we solve this, it is r equals to 0.09966 centimeter. Okay, and what was v? It was 1 by r, so we have to just take reciprocal of this. So v2 is equals to 1 by 0.09966, and after taking this reciprocal, this value will come as v2 equals to 10.03 volts. This will be the answer for this question. So you have to just think of like this, in this way, that it is a spherical capacitor and you have to solve this in this way. Okay, right. Now let us see one more question. Charge is distributed in spherical region r less than 2 meters with volume charge density as this relation is given, is non-uniform. So what net flux crosses the surface r equals to 1 meter? r equals to 1 meter के surface को कितना net flux cross करेगा? So you can easily think of, this is a problem based on Gauss law. This is a problem based on Gauss law. As Gauss law says that the net flux crossing through a surface, if we consider a closed surface, it will be equals to the charge enclosed by it. So if you think of like here, this surface is of r less than 2 and its volume charge density is given as rho v by this relation, and we have to find the net flux which is crossing a surface r equals to 1 meter, r equals to 1 meter. So I have to consider a Gaussian surface of r equals to 1 meter. Then I have to apply Gauss law. What the Gauss law says is that the charge enclosed, or the flux passing through the closed surface, will be equals to the charge enclosed by it. So what will be the charge enclosed by it? It will be rho v dv, the volume of this sphere, and as it is a spherical coordinates, so what will be the differential volume? So first I will write the rho v value, which was minus 200 by r square, and remember, carefully think of the unit that here is given in microcoulomb. So it is minus 200 by r square, and you have to write dv. So in spherical coordinates will be write r square sine theta dr g theta d phi, right? So r square will get cancelled, the things remaining will be minus 200 will come out, and it is in microcoulomb, so remember that also. So our answer will be in microcoulombs easily. So here sine theta, dr is also remaining, dr, so limits of r will be 0 to 1 meter, and sine theta d theta, sine theta d theta from 0 to pi, and d phi from 0 to 2 pi. So if we solve this, this will come as 200 and this will come as 1, this will be 2, this will be 2 pi. So it is 2 into 2, 4 pi, 4 into 2 is minus 800 pi microcoulombs is the charge present in this surface, and that will be the net flux crossing the surface of r equals to 1 meter, right? So easily you can find out what is the net flux. That is the net flux, that is minus 800 pi microcoulomb, right? Now let us see one simple question. Here d vector is given, displacement flux density e to the power 5x ax cap 2 cos y ay cap plus 2 sin z az cap coulomb per meter square. You have to find volume charge density at origin. So if you remember the Maxwell's first equation, that was del dot D is equals to rho v. So in this way you can easily find the volume charge density, right? You can easily find the volume charge density by this equation. You just have to find the divergence of this displacement flux density. So in Cartesian coordinate system, the formula for divergence is del by del x of dx plus del by del y of dy plus del by del z of dz. This will be equals to the volume charge density. So just we have to find out the divergence. So del by del x of dx component is 5 e to the power 5x plus del by del y, and it is the y component is 2 cos y plus del by del z of the z component is 2 sin z. You can first note this thing and then watch this to understand that what I'm writing. So now just what you have to do, you have to just do differentiation. So e raised to 5x differentiation will be 5 e raised to 5x plus here the differentiation will be minus 2 sin y, and here the differentiation will be 2 cos z. Now you have to find the volume charge density at origin. So you have to put what? 0 0 0 in place of x, y and z. So if you put x equals to 0, so at 0 0 0 it will be what? 5 e to the power 0, e to the power 0 will become 1 minus 2 sin 0 will be 0, so it will be gone, and cos 0 will be 1, so it will be this. So it will be easily what? 7 coulomb per meter cube. So this will be the volume charge density for the given question, for the given displacement flux density 7 coulomb per meter cube. This was an easy question. Now let us see next question. The charge needed when within a unit sphere centered at origin for producing a potential field, this this potential field, for this potential field what will be the charge needed within a unit sphere. So what you have to do here is to find out the charge to produce this potential by that charge, and it is a unit sphere. Okay, so using this potential we can find electric field by the relation E is equals to minus gradient of potential. So you have to apply the formula for gradient. What is that? And it is in spherical coordinate. So in spherical coordinate the gradient formula is 1 by r square del by del r, where r square into v, and the other components will become 0 only, because here only r component is present. I mean r is only there, no theta and no phi. So if you solve this, here if you put minus 1 by r square into del by del r of r square, and the value for v was minus 6 r to the power 5 epsilon naught. So if I put that minus, so this minus will gone, and this will be 6 by r square, uh, 6 r to the power 5, 6 r to the power 5 by epsilon naught. And for gradient this is not there, this is for divergence basically. So we have to just put here what the value of V, and the minus sign will be gone. So here also I have to remove this R value, so it is just what minus del V by del R. So minus is also there in V, so the minus sign will be gone, and the remaining thing will be del by del R of 6 R to the power 5 epsilon naught. So if you solve this, it will be 30 R raised to 4 epsilon naught. And here the direction is AR cap, right? Because it is a gradient, so it's gradient किसी स्केलर का निकालोगे वो क्या आएगा, वेक्टर आएगा, ठीक है. तो ये आ गया E. Now you have to find the charge. For finding the charge you have to find the uh, displacement flux density. Then we will apply Gauss law and we will find the charge. So D will be what, epsilon naught E, simple. So if I multiply this by epsilon naught, so it will become what, 30 R raised to 4 AR cap, right? And now using Gauss law, D dot ds will be equals to what, Q enclosed by the unit sphere. So here the D is 30 R raised to 4 and ds will be here AR cap, so ds will be what, R sine theta, basically R square sine theta, D theta D phi, because AR component I need, so this will be the value of ds and this will be equals to Q. Okay, so if I put the value now of the 30 will come out here, R to the power 6, and it is a unit sphere, so it will automatically becomes 1 to the power 6, that will be 1 only. And for sine theta d theta, the limits are from 0 to pi, and for d phi the limits are from 0 to 2 pi. This is the value of Q. So if you solve this, will come as 30, and after solving this will be 2 pi, not 2 pi, this is just 2, and solving this is 2 pi, and this will be 2 into 2 4, 4 into 30 is 120, so its answer will be 120 pi coulomb. So let us see if from the given option which one was correct. So here you can see this option C, 120 pi coulomb, is the correct option. So in this way you can find the value of charge Q. You have to first find E, then D, then apply Gauss theorem and find the charge for a given potential field. Okay,